The 16th century was a century full of upheavals. Martin Luther wrote his 95 Theses, hammered them on the door of the All Saints' Church of Wittenberg, and thus triggered the Reformation. In addition, in 1543, the astronomer Nicolaus Copernicus represented the heliocentric worldview, according to which the Sun, and not the Earth, is the centre of our solar system. Both events greatly influenced contemporary history and triggered religious and scientific tensions. Thus, one also speaks of the Copernican Revolution. Johannes Kepler was born on December 27, 1571, in Wilderstadt, near Stuttgart, in the Holy Roman Empire, and his life was marked by numerous adversities, partly because of these tensions. His father was often absent, and his mother aroused his astronomical interest at an early age, such as the Great Comet of 1577. He survived a smallpox disease at age 4, but it permanently affected his eyesight. He also suffered financial hardship for a long time and, as a Lutheran, was often persecuted during the Counter-Reformation. For example, he left Graz towards the end of the 16th century because of religious intolerance, which was to befall him more than once, especially during the turmoil of the 30 Years' War, 1618 to 1648. While teaching in Graz, Kepler claimed to have had an epiphany on July 19, 1595, demonstrating the periodic conjunction of Saturn and Jupiter in the zodiac. He realized that regular polygons bound one inscribed and one circumscribed circle at definite ratios, which, he reasoned, might be the geometrical basis of the universe. He corresponded several times with Galileo Galilei and accepted an assistant position with the famous Danish astronomer Tycho Brahe in Prague. Both had different talents that complemented each other perfectly. Brahe was an excellent observer, but his mathematical abilities were not as strong as Kepler's, even if there was a dispute in the meantime, which caused Kepler to temporarily leave the observatory because Brahe often treated his assistants with little respect. This collaboration was overall extraordinarily fruitful. After the death of Tycho Brahe in October 1601, Kepler was immediately appointed imperial mathematician and remained in Prague for several more years. In October 1604, Kepler observed a supernova, later called Kepler's star, which put a new damper on the prevailing view that stars were fixed. In 1609, his most famous work that he had worked on for several years, Astronomia Nova, A New Astronomy, was published. It contained the first two laws of Kepler's orbital mechanics. The first law states that the planets in our solar system orbit in elliptical orbits and that the Sun is at a common focal point. This is extraordinary in that most planetary orbits in our solar system have little eccentricity. Furthermore, this was a decisive improvement of the work of Copernicus, who still assumed circular orbits. The second law states that the connecting straight line from the Sun to planet sweeps the same areas at the same times. And this statement is an example of the law of conservation of rotation. Another of Kepler's important works was his dioptrice. With this work on the dioptric of the eye, published in 1611, Kepler laid the foundations for optics as a science. In 1615 to 21, Kepler's 69-year-old mother was tried in a witchcraft trial and was imprisoned for over a year. Although she also had to endure a penetrating interrogation in which she was shown the instruments of torture, fortunately, probably due to Johannes Kepler's high reputation, she was acquitted and thus escaped the stake, unlike Kepler's great-aunt and dozens of other women from his birthplace. It can be assumed that this period left its mark on Johannes Kepler. Yet in 1619, he published Harmonices Mundi, the harmony of the world, which contained the third law of planetary motion. This law, in conjunction with Newton's gravitational constant, still plays a fundamental role today in determining the parameters of an exoplanet. It states that the squares of the orbital periods of the planets behave like the cubes of the great semi-axis on their orbit around the Sun. This law results from the approach centripetal force equals gravitational force. But in 1619, Kepler suffered the next setback when the Vatican forbade his work, Epitome Astronomiae Copernicanae, epitome of Copernican astronomy, by representing the conviction that our Sun is only an ordinary star and that planets orbit other stars. More special work is Somnium, the Dream, published in 1634, 4 years after his death, which is one of the first science fiction works in the history of literature, in which a lowly deity enables a man to travel to the moon from Iceland. Thereby, Kepler already describes, amazingly well, the occurring physical forces of acceleration which are necessary to leave Earth's gravitational field, and he also reports the cold and the weightlessness of space. Furthermore, he is convinced that such a journey would be very stressful for the human body. In general, Kepler was firmly convinced that not only the Moon, but also the other planets of our solar system, such as Jupiter, are populated by living beings, as he wrote in his letter Dissertatio cum Nuncio Siderio, Conversation with the Sidereal Messenger, to Galileo Galilei in 1610. He died in Regensburg on November 15, 1630. A Kepler monument was erected in 1806-08 by Emmanuel de Hérigoyen near the former burial site. The passage in the epitaph reads, "I have measured the heavens. Now I measure the shadows of the earth. Heavenward strove the spirit. The body's shadow rests here." Kepler is a key figure in the scientific revolution, and the Kepler Space Telescope is named after him. In addition, a lunar crater and a Martian crater each bear his name.